Today, we'll be looking at the 4 most promising worlds for alien life in the solar system. If you're new to this channel, welcome. This is Mr. Singularity, where we explore the scientific and technological breakthroughs shaping the future as we know it. The Earth's biosphere includes all the recognised materials that are essential for existence as we know it. Broadly speaking, they are liquid water, at least one energy source, and an inventory of biologically valuable elements and molecules. But the latest observation of probably biogenic phosphine in the clouds of Venus tells us that at least some of these components occur elsewhere in the solar system as well. But where are the most promising places for extraterrestrial life? Mars. Mars is one of the most Earth-like planets in the solar system. It has a 24.5-hour day, polar ice caps that extend and compress throughout the seasons, and a vast variety of surface structures that have been sculpted by water over the history of the world. The discovery of a lake under the southern polar ice cap and methane in the Martian atmosphere, which changes with the seasons and also the time of day, allows Mars a very fascinating life prospect. Methane is essential since it can be generated through biological processes, but the exact source of methane on Mars is not yet established. It is probable that life may have achieved a foothold, considering the proof that the Earth once had a far more benign climate. Still, Mars has a very small dry atmosphere, nearly completely made up of carbon dioxide. It provides scant defense from solar and cosmic radiation. If Mars has managed to maintain any of the water supplies below its soil, it is not unlikely for existence to continue to live. Europa. In 1610, Europa was found by Galileo Galilei, along with Jupiter's 3 other larger moons. It is marginally bigger than the Earth's moon and orbits the gas giant at a distance of some 670,000 kilometers every 3.5 days. Europa is continuously crushed and strained by the opposing gravitational forces of Jupiter and the other Galilean moons, a mechanism known as tidal flexion. The moon is thought to be a geologically active planet, like Earth, since the intense tidal flexion heats its rugged metallic interior and leaves it partly molten. The floor of Europa is a large expanse of frozen water. Many scientists claim that underneath the frozen ice there is a layer of liquid water, a vast ocean, which is stopped from freezing by heat from flexing, and which can be more than 100 kilometers thick. Proof for this ocean involves geysers erupting from underwater ice fractures, a weakened magnetic field, and an unstable underwater ground that may have been deformed by waters flowing under. This ice shield isolates the subsurface ocean from the intense cold and void of space, as well as the Jupiter's ferocious radiation belts. It is possible that we will discover hydrothermal vents and ocean floor volcanoes at the bottom of this ocean planet. On Earth, these features also benefit very rich and varied habitats. Enceladus. Like Europe, Enceladus is an ice-covered moon with a subsurface ocean of liquid water. Enceladus orbits Saturn and first come to the notice of scientists as a possibly habitable planet after the surprise observation of massive geysers at the south pole of the moon. These jets of water escape from large cracks on the surface and, provided the poor gravitational field of Enceladus, they spray into space. They are direct evidence of a deep reservoir of liquid water. Not only has water been found in these geysers, but also an assortment of organic molecules and most notably tiny grains of rocky silicate particles that can only be present if the subsurface ocean water are in close contact with the rocky ocean floor at a temperature of at least 90 degrees Celsius. This is very clear proof of the presence of hydrothermal vents on the ocean floor, supplying the chemistry required for life and concentrated energy sources. Titan. Titan is the main moon of Saturn and the only moon in the solar system with a large atmosphere. It includes a dense orange cloud of complex organic molecules and a methane weather mechanism instead of water, complete with periodic rains, dry seasons and surface sand dunes formed by waves. The environment is mainly made up of nitrogen, an essential chemical factor used in the production of proteins in all recognised types of life. Radar surveys also reported the existence of rivers and reservoirs of liquid methane and ethane, and probably the emergence of cryovolcanoes. Volcano-like characteristics of salt water rather than lava. This indicates that Titan, like Europa and Enceladus, has a subsurface reservoir of liquid water. For such an incredible distance from the Sun, Titan's surface temperatures are a frigid 180 degrees. A little too low for liquid water. However, the plentiful chemicals accessible on Titan also contributed to theories that life forms, potentially with radically different chemistry to terrestrial organisms, that could occur. If you made it this far in the video, thank you and welcome to the end of the video club. What's your take on this? Let me know down in the comments below and check out one of these other videos. This has been Mr. Singularity and I'll see you on the next one.